All right, let's get right into it. Today, we are opening up the ultimate algebra toolkit. We're going to stock your problem-solving arsenal with 5 core concepts that are, frankly, game changers. I know, sounds a little dramatic, right? But seriously, what if you could actually predict the future? Or make sense of ridiculously complex problems? Or maybe even decode the hidden rules that run the world around us? Well, here's the secret. Algebra kinda does give you those powers. You see, these aren't just dusty old rules from a textbook. They are legitimate tools for thinking. And today, we're adding 5 of the absolute best to your personal toolkit. So let's get to it. Okay, our first tool is all about seeing the future, well, mathematically speaking, of course. It's the power to spot and predict patterns using something called sequences and series. So at its simplest, a sequence is just a list of numbers that follows a specific rule. Like this one, 2, 4, 6, 8. Your brain immediately knows the next number is 10, right? You just spotted the pattern. But what happens when those patterns get a little trickier? Well, that's where 2 main types come into play. First, you've got an arithmetic progression, or AP for short. That's where you just add the same amount each time. Think slow and steady growth. But then, you have a geometric progression, or GP. Here, you multiply each time. And that's when things start to get interesting and fast. And this is exactly why it matters, big time. Linear growth, that's your AP, is like saving $10 a week. Predictable, steady. Exponential growth, your GP, is like a social media post going viral. Understanding that difference is absolutely crucial for everything from your savings account to understanding how populations grow. All right, tool number 2 is a lifesaver. It's a fantastic shortcut. I mean, if you've ever had to multiply something like a plus b by itself over and over again, you know it's a total pain. Well, the binomial theorem is your secret weapon. Really, all it is a formula that does all that tedious work for you. It's the easy button that gives you a clean, direct path to expand any expression that looks like a plus b raised to some power. Let's just look at an example. So, a plus b cubed. Instead of all that messy, long multiplication, the theorem just lays out this beautiful, clean pattern. You see how the power of a goes down while the power of b goes up? And those numbers in the middle, they follow a perfect pattern too. That's the hidden structure it unlocks. And trust me, this is way more than just a trick to finish your homework faster. This kind of pattern is at the heart of probability theory and even the financial models that calculate risk. It's all about finding an elegant solution in the midst of complexity. So our third tool helps us wrestle with giants. I'm talking about making numbers that are just ridiculously, mind-bogglingly huge seem small and manageable. Let's talk about logarithms. Now, to really get logarithms, you gotta be friends with their alter ego, exponents. You probably remember these rules, right? How we add exponents when we multiply them when we raise a power to a power, all that good stuff. But what if you need to find the power itself? Boom. That is exactly what a logarithm does. It answers the question, what exponent do I need to get this number? So we all know 2 to the power of 3 is 8. The logarithm just flips that around and asks, 2 to the power of what gives me 8? And the answer, of course, is 3. It's just the other side of the same coin. So why should you care? Because this is how we make sense of massive scales in the real world. You know the Richter scale for earthquakes or pH levels in chemistry? Both use logarithms to take these wild exponential changes and sort of squish them down into a simple scale from 1 to 10 that we can actually wrap our heads around. Okay, so we've figured out how to handle huge numbers, but what about a huge amount of numbers? In a world that's basically drowning in data, we need a system to keep it all straight. So let's meet our 4th tool, the matrix. And no, I'm not talking about the movie, though this is almost as cool. Don't let the fancy name fool you. A matrix is simply a grid of numbers. That's it. A box with rows and columns to hold information in a really organized way. Just look at this little guy here, a basic 2x2 matrix. Think of it like a mini spreadsheet. Every single number has a precise address. So that number 3, it lives at the corner of the 2nd row and the 1st column. This super simple grid structure is what makes matrices so incredibly powerful. So why does a simple grid of numbers matter so much? Oh, it's a huge deal. Every time you see a 3D character jump in a video game or an architect designs a building on a computer, matrices are running like crazy in the background, calculating position, rotation, you name it. They're the invisible engine of modern technology. And finally, our 5th tool. This one, This is basically the language of mathematics itself. It's how we describe the rules that connect things. We're talking about relations and functions. Okay, so a relation is any old link between two sets of numbers. But a function is special. It's a strict rule. For every single input x, you get exactly one unique output y. Think of it like a trustworthy machine. You put one thing in, you get one specific thing out every single time. And that's really the whole point, right? Functions let us model the world around us. The relationship between how far you drive and how long it takes. That's a function. How much your groceries cost based on their weight. Also a function. They give us the power to describe, analyze, and even predict how everything connects. So there you have it, 5 powerful tools for your kit. We've got progressions to predict patterns, the binomial theorem for powerful shortcuts, logarithms to tame giant numbers, matrices to organize all our data, and functions to describe the relationships between everything. Your mental toolkit just got a serious upgrade. And remember, this stuff isn't just for a math test. It's for understanding the world in a whole new light. So the only question left is, what are you going to build with them?